Good morning. Now, in all these cases what we were discussing is how to produce a particular product better, so that you can make profit out of it. So, as we have seen that this is typically related to what is known as economy of scale, that is, if you can produce a product in a much larger volume by using very sophisticated machines, then because of the blessings of automation you can gain lot of profit, that is called the economy of scale. But there is a totally different kind of economy which is becoming more and more important in the which has first shown its significance in the later half of the 20th century, and it is going to be all important in the 21st century, and that is called the economy of scope. Now, what is the economy of scope? To be able to understand that, we have to first look at the manufacturing environment. So, the manufacturing environment today is actually very dynamic. Now, what do I mean by that? To be able to understand that, you have to first understand that how a given product, what is the life cycle of a given product, that is, right from the time of conception, what are the phases through which it goes, so that it finally is produced and sold in the market, and eventually dies a life of natural death and another product comes into existence, gets conceived, gets designed, gets manufactured and gets sold. So every given product actually has a particular lifetime. So, to be able to understand that, the first phase is product conception and product design, right. After that you have, if you want to, so at this stage you have conceived a product that you want to make this thing. After that you want to, and you have also designed it, but once you have designed it, you have to actually plan and you have to actually install equipment so that you can manufacture it. So, you have to set up your factory, you have to change your production facility, right. After that you have to actually do production, that is when you have to actually do production and you have to do quality control, and at this point of time it will go out of the factory into the marketplace and will get sold. Now, in the marketplace, from the marketplace you will get feedback, of various kinds from consumer surveys, plus there is continuous R&D is going on. So, people are going to come up with better material, with better manufacturing processes, with better controls, which will enable you to conceive new products which are improved, which will sell much larger, probably cost of production will be less. So, you again conceive a new product, again you design it, again you make process planning installation and again you produce it. So, you see, this is a cycle, that a product from its time of conception up to its time of selling has a certain life. Now, this life is crucially affected by manufacturing systems. So, now let us look at what is happening to this situation. So, excuse me. So, here we have the economy of scope, and what are its features? See, competition and R&D are continuously causing product development, continuous product development is going on. So, all old products are getting replaced by new products, and this is continuous, right. which means that product, for a given product, its life cycle is getting continuously reduced. Look at the PC market today. Roughly in 6 months time, you are getting newer and newer versions of PCs. Change is coming from the cabinet to power supply to motherboard to RAM to displays to software. Everywhere there is change. Now, these are very sophisticated equipment. Just imagine that an equipment as sophisticated as a motherboard has to be designed, it has to be produced, it has to be marketed, sold, and after 6 months it is going to be defunct, it is going to be obsolete, to be replaced by another product. So, within 6 months it is, everything will have to be done, product will have to be sold and profit will have to be made. So, the product lifetime has shrunk dramatically. What does that mean? It means that product life cycle, since product lifetime is less, so the whole product life cycle of conception, design, process planning, installation, production, everything will have to be accelerated. How can you accelerate it? You can't accelerate it, you can't make new and new designs very fast, you can't produce them fast without having manufacturing systems which are rapidly reconfigurable. So, you have to have machines which can today make PCBs like this, tomorrow make PCBs totally entirely different PCBs, right. So, they have to be rapidly reconfigurable, and therefore, you need, so this all these, how can a manufacturing system be rapidly reconfigurable? It can be rapidly reconfigurable only with the help of automation. So, unless you have, that is one aspect. Second aspect is that unless, suppose you have built a machine. Now, if the machine may be very good, fantastic, absolutely efficient for a product X. Now, if it is only meant for product X, then you will always think in this volatile market that suppose product X goes out of fashion, what is going to happen to my machine? I am spending so much money on it. Secondly, using this machine, if there is not enough demand of product X, can I also manufacture product Y from the same machine? So, can I explore other markets? So, can I rapidly reconfigure my manufacturing system, so that sometimes I manufacture product X, sometimes I manufacture product Y, and sometimes I manufacture product Z. If I can do that, then I can utilize my machine and I can take the benefit of 3 different markets. So, for this also reconfiguration is necessary. So, this is what is the economy of scope, and 21st century automation systems will enhance this economy of scope significantly. Now, let us look at the kinds of production systems that typically exist, that is a broad categorization of production systems. So, typically production systems are categorized broadly into continuous processes and continuous manufacturing and discrete manufacturing. So, things which you can count as 1, 2, 3. So, you have watches, you have bicycles, this is manufacturing, discrete manufacturing. On the other hand, things which you generally measure not as numbers, but as quantities like oil, steel, cement, that is a continuous process, right. So, again continuous processes could be divided into 2 kinds. One are called continuous flow processes. Typically, it means that a product is manufactured for a considerable amount of time and continuously the product manufacturing goes on, like the case of, let us say, oil refineries or the case of steel plants. Very big factories manufacture maybe 4 or 5 kinds of products, maybe let us say gasoline, petrol, kerosene. These are typical product types of a refinery. Similarly, you could have a batch process where the product quantities are more in I mean the product varieties are more in number, but the product quantities are less. Typically is pharmaceuticals or let us say paints. So, you have a larger number of products, they are still continuous processes, but each gets manufactured in smaller quantities. Exactly similar categorization exists for discrete manufacturing. One kind is that where there is less number of variety gets produced in huge numbers, let us say bicycles or some appliances, some factory produces mixers or produces televisions or produces. So, on the other hand, contrasted to that, there is a kind of factory called job shops. For example, let us say a machining factory. So, every customer comes with a drawing, so with a new drawing. So, every piece that you are manufacturing, probably every customer gives an order of 100 pieces, 2000 pieces like that, but every customer comes with a unique product which not only involves different geometries, but also might involve different manufacturing processes like turning, drilling, grinding, milling, and they may be applied in different sequences. So, every job is new. So, this is the categorization of production systems, and if you organize them, then you will see that how they look on the quantity variety chart, right. So, on this side this is a graph, and on this side you have the quantity for each given type of product, and on this side you have variety of the types of product that factory produces. So, on the these are continuous flow processes where the product variety is probably lowest 3, 4, 5, but huge quantities of that of each product gets produced. So, some basic industries like oil refinery, iron and steel, some chemicals, cement, paper, fertilizer. So, these are typically continuous flow processes. On the other hand, discrete manufacturing is the counterpart of continuous flow processes. There you have mass manufacturing of discrete products, so appliances, bicycles as we have discussed. In continuous processing you have foundry shops where molten metal becomes casting, and then each casting is actually different, casting metals could be different. So, food processing, so various kinds of foods get prepared. So, here again variety is more, each variety production quantity is less, and at the extreme you have job shops where every product that you are getting is likely to be a new product, right. So, these are basically what we are trying to categorize these production systems into are firstly in terms of the quantity that is produced. So, and secondly in terms of the types of products. So, the flexibility required in manufacturing, right. So, now we will see that for these various types of production systems, how the various types of automation systems, they are each one will be now suitable for given types of industries. So, we have, let us see the various types of automation systems again categorized into 4 types. So, the first, they are fixed automation, programmable automation, flexible automation and integrated automation, right. So, let us see what each are. So, if you go to flexible automation, rather fixed automation first. So, in fixed automation you have, what are the features? The features are that you have generally used for very high volume of production. So, you need to really tune your automation to that particular production. Equipment is very dedicated, products are not likely to change. For example, the iron and steel industry cannot really, I mean the product variations is still is there because of metallurgical research etc., but it is much slower process and generally products lifetimes are much larger. So, there you can and the volume is so large that by building dedicated equipment you gain so much money that it makes sense to have dedicated equipment which is low in flexibility, but very highly efficient for that manufacturing process. So, you have basically you have a very fixed and efficient operation. So, for example, the let us say the blast furnace or the steel melting furnace or the continuous caster, these are equipment which are likely to have a long life. So, and they handle so much of equipment, so much of so much of material, so much of energy that it makes sense to make them very tuned for efficient production. So, factory types are typically continuous flow and discrete mass productions. Okay. Cycles, most parts of the cycle are likely to live for a much longer time than let us say a fancy watch. So, examples are process automation controls for these kind of steel, oil refinery kind of things. For example, there are some parts of automation which do not need to be changed, when there is not much to change it. For example, conveyors remain nearly same always. So, that is a fixed automation. Paint shops, generally painting is that you need to put the object at one place and you need to spray jet the paint. So, the operation itself is simple, is not likely to change very much. Transfer lines. So, for example, the Maruti 800 stays the Maruti 800 for a long time, keeps changing, but changes are not very significant changes. So, each part remains unchanged for reasonable lengths of time to make the investment on dedicated equipment meaningful. Now, gradually if you go for, let us go for programmable automation. Programmable automation is one where you need to make changes more frequently, may not be every day, may not be every hour, but you still need to make change perhaps once in a week or once in a month. So, since the basic equipment life is going to be much more than a month, so you need to make it programmable. So, that is reasonably easily you can change the sequence of operation. So, that is, so it has changeable sequence of operation and it has electronic controls. So, that is why it came first, it came into existence in numerical controls for discrete production. So, again you have batch process, you have mass production where you still have mass production, but now your product variety has increased. So, you need to make changes. So, it should be reasonably fast, probably it need not be done by operators, but it can be done by engineers within, let us say if you want to change it every month, then probably for changing you need to take less than a day, that kind of automation. So, examples will be, let us say, numerically controlled machines, various kinds of assembly robots which will pick a part and put it at a different place. So, if the sequence changes, then this assembly robot also needs to be changed, so that it can now pick parts from a different place and place them at a different place perhaps. Contrasted to this, as the economy of scope increases, we have various kinds of industries where things will change very fast, right. So, there we have flexible automation. So, now changes will be made several times in a day and changes will have to be made by operators. So, and they have to be made fast, because if the change takes time, then you are going to lose out on idle time. You want to maximize production time. So, machines are now computer controlled, maybe with graphical user interfaces, so that the operators know how to operate it and can give very many of these changes should be pre-programmed. so that the operation just, so the operator typically chooses certain configurations from a makes a choice, probably adjusts some parameters, and the rest is done automatically. Similarly, material handling should be also programmed, because if the sequence changes, then parts will have to travel from one place to another. And so if you use material handling equipment for which is fixed, then you cannot transfer parts from one place to another very flexibly. That is why you need programmable material handling. So factory types are job shops, where every part requires a different sequence, and also could be batch processes, where depending on batch size, the sequence of process operations will change. So the examples are CNC machining centers and guided vehicles, automatic guided vehicles. Now still all these, that is fixed, programmable and flexible, they are mainly concerned with automation over a limited spatial range. So you are talking about local automation, maybe within a shop, or maybe within parts of a shop, or maybe involving just one or two machines. Now if you want to really control the whole factory in a very integrated manner and in a very optimal manner, then what you need is that you need to exercise this automation. You need to integrate all the automation systems and make them coordinated and make them talk to each other. So that is called integrated automation, where you have whole factories under automation systems. So what are these features? First feature, these are actually they are the most expensive variety of automation, and they are firstly characterized by advanced optimizing algorithms. That is, there is a lot of knowledge built into these machines. They actually do a lot of mathematical calculations based on very sophisticated models, and there are very few vendors who have got that knowledge, and they generally do international business. So international companies like, let us say, Voest-Alpine, they are steel making consultants, and they give their consultancies to factories the world over, right. So they use very advanced knowledges and algorithms, obviously based on computers. Then one of the essence of these factories is that they have a lot of communication. So you have to integrate various parts. So you have computer communication, and here gradually the trend in automation is that production and management must be integrated. That is, right from the order bookings at the marketing offices, they must be quickly, very all aspects of the business must be harmonically operated. And so if you suddenly get more orders, immediately material procurement may be going on, production facility augmentation will go on, inventory capacity will be changed. So things are tuned and just operate like an orchestra, right. So this is what gives the name of integrated automation. So typically these could be applied to all types of factories, but since they are so expensive, so generally they are actually applied to very large factories, because otherwise the cost cannot be justified. And typical examples are let us say chemical process automation, big chemical process automations, and or otherwise plant wide CIM, which stands for computer integrated manufacturing. So now we have seen that as we go for various kinds of factories, you also need various kinds of automation for them. So for machines in steel plants, you may be requiring very fixed type of automation locally, but for coordination, for example, coordination between the steel melting shop and the continuous caster. You see, in the steel melting shop you are pouring out hot steel. So this hot steel has to be taken by a material handling system to the continuous caster, where it has to be cast. Now if for some reason this continuous caster and steel melting shop are not synchronized, then your ladle in which you are carrying the hot metal and you are taking to the caster, that may have to wait at various places due to various problems, and in this process it may get cold, and in the continuous caster, if there are certain conditions, I mean you can only pour this steel into the continuous caster when the steel has a certain temperature. So, if due to coordination lack you cannot ensure effective coordination, then it may happen that you can suffer very large losses, because a particular ladle could not be put into the continuous caster and had to be say put into the slab caster, where the steel will sell at a much lower price. So, for steel factories you need one kind of combination. On the other hand, you nowadays if you have a bicycle factory, there are people are thinking that people will book orders on the net, people will assemble their own parts on the web and give an order for a customized cycle for that customer. So, he will choose a particular type of seat, a particular type of handlebar, a particular type of gear ratio, wheel diameter, tire type, what not. So, every order now becomes a customized order. So, you see a factory which was essentially a mass manufacturing it is trying to manufacture the same volume, but it is trying to increase the variety just to capture markets. So, and this is being made possible by very advanced automation. So, this brings us to the end of our lecture, and before we end, let us review our lessons. So, what have we done today? We have seen a definition of industrial automation, and well, we have discussed about automation. Control, most of us know because we have already had a course in control. Actually, control is actually a part of automation and actually talks about only the day to day, I mean minute to minute operation, giving input, getting output, that is called control, while automation is much larger in scope, both geographically and over time and over functionality. So, we have seen that definition. Then we have defined our course objectives. We have underlined the role of automation in industry and how it can help you earn profits. We have distinguished between economy of scale and scope. We have shown the various types of production systems and their different types of automation systems. So, this is what we have done in brief, and here are some questions which you can look at. For example, you could try to give examples of how industrial automation enhances economy of scope. You can give an example from a particular type of industry. You can also enhance in a given industrial context how it reduces cost of production. You can define automation and distinguish it from control, give it an example, or explain suitability of various types of automation systems in specific industrial situations. So, that is all for today. Thank you very much. We will see the architecture of industrial automation systems in our next lesson. Thank you very much.